Welcome. We are going to discuss the concavity of f of x using second derivative. This is a chapter 3.4 and it is a page number 26 in your packet. So let's talk about what's the objective. Objective is that we are going to determine the intervals on which the function is concave up or concave down. Let's make connection what our basic understanding of concave up, concave down. Find any points of inflection. Points of inflection means where the graph changes concavity, and second objective is apply second derivative test. We will do this in class. I'm only going to show you how to determine function is concave up or concave down. So let's read here. If we know the function has a positive derivative over an interval, positive derivative, straight away make connection. That means f prime is greater than 0. We know that the graph of the function is increasing. We know f prime greater than 0, function is increasing. But we are going to find out how fast it is increasing, what rate it is increasing. It is increasing faster or slower. And for that part, we need to look at the second derivative. Okay, so let's take a look at these two examples here. The both functions are increasing. You can see that the both are going from point A to B, point A to B. But they have a different curvature. Curvature means concavity. The function on the left increases at increasing rate. So how do you find this rate increasing at increasing rate? The easiest part to check is draw the tiny tangent lines. Let's take a look at here. The tangent line is, draw the tangent lines and see that the slope of this tangent line is increasing. We know that the f prime is positive because function is going up, but the slope of those tangent lines are also getting higher and higher. Now take a look at here. If I draw the tangent lines, you can see that my tangent line is getting flatter and flatter. That means slope of my tangent line is getting smaller and smaller. So the easiest way to figure out whether the function is concave up or down is try to draw the tangent lines and then see if it is concave up or concave down. Like a cup, concave up, frown, concave down. So this is a very easy example here where you are already given f of x. You are just trying to figure out that concave up because tangent lines are above, concave down. So this is CC up. This is very common acronym to write CC up. I'm sorry. This is CC down. CC down, CC up, down, up. You can clearly see that where function is CC up or CC down. Now, one thing you have to make sure you know that concavity is always over the interval. Concavity is over the interval, which means you cannot write concavity at x equal to some number. It is always on the interval and it is always open interval. So here you can say that the function is concave down on the interval a to b. You can never say concavity at one point. Concavity can never occur at one point. It has to be over the interval. So if the slopes of f are increasing, understand slopes of f are increasing. F is increasing, which means f prime, but the slope of f is increasing, which is f prime greater than 0. Slope of f are decreasing, which means f prime is less than 0. So let's take a look at the next page and we try to define some definitions in the concavity. So that will be your page number 27. This is page number 27, your page number 27. Okay, so let f be a differentiable function on the open interval. The graph of f is concave up if f prime is increasing. F prime is increasing, which means prime is greater than 0. Let's make connection again. Concave up, f prime is greater than 0. Concave down, f prime is less than 0. So This is very important fact which you have to know all the time about the concavity. Now, how do we apply the test for concavity? To look at the test for concavity, we have to say that f prime, it is the same connection here. F prime is increasing means prime greater than 0. F prime is decreasing means f prime less than 0. So these two are pretty much same. We can say that f prime is greater than 0, then here we are saying f is concave up, then f prime. Here f prime is greater than 0, then function is concave up. F prime less than 0, function is concave down. I recommend that all the time you draw this line, because all the time students are making mistake about concavity. Always try to draw the picture next to it. This is concave up, that means relative minimum. Concave down will have relative maximum. Okay, so what is another keyword here is a point of inflection. What is point of inflection? This is another question where you will be asked to find a point of inflection. Point of inflection means a point where graph changes concavity. For example, if I have something like this is called point of inflection. Very common acronym is POI, where graph changes concavity. That's called POI, point of inflection. How do we find a point of inflection? There is a procedure to find a point of inflection, and that's what we are going to look at that. So point of inflection is where second derivative is 0 or undefined. Second derivative is 0 or undefined. There are two conditions. Second derivative has to be 0 or undefined, and f prime changes sign. It could be positive to negative or negative to positive. If we write in terms of f prime, we know that the relationship between all those f prime and prime. So we are going to look at original function f has a point of inflection where the second derivative is 0 and prime changes positive to negative. That means concave up to concave down. If you are excuse me, if you are given f prime of x graph and you have to find concavity, you cannot use prime. You have to write in terms of f prime, which is f prime of x changes from increasing to decreasing or decreasing to increasing. Now I prefer this third one. Please write this down. This is very common and acceptable. AP like this. AP accept this. AP College Board accept this. Answer is if f prime changes increasing to decreasing, this is f prime graph, then obviously there is a relative extrema. So why we write so much here, increasing to decreasing? If you are given f prime graph, first derivative graph, and if you have to talk about the concavity, please use this simple statement that f prime of x has a local extrema at x equal to c. That's where you have a point of inflection. So once we understand all these things, you will have to make a connection between f prime and prime. So we will do some practice problems in the classroom where you have to do the matching. Which graph is the original one? Which one is the first derivative? Which one is the second derivative? But before that, let's do some basic things. How do we identify from the graph, and how do we do the problem given the equation? So graph of f is shown below. State the signs of f prime and prime on this interval. So clearly this is f of x, which is decreasing. So we know that f prime of x has to be less than 0. Why? You can say f of x is decreasing. Okay, how about f prime? Well, try to draw the tangent line. Do you see tangent line is below? So you can say f prime is, I'm sorry guys, I'm trying to write f prime of x will be greater than 0 because graph is clearly concave up. So you can say as f of x is CC up, which means sometimes you have to know that the tangent lines are below. Those tiny tangent lines are below. So given a graph, it's so easy to see, figure out concave up, concave down. Let's take a look at the example where we have to do from the equation. This is very important to understand the procedure, what to do. So pay extra attention. This question is straight from the textbook problem. If you don't understand what am I doing here, please refer to the textbook, or you can use the Khan Academy as well. Okay, so determine the open intervals. Interval concavity is always over the interval. One more time, I'm making connection. Concavity is never at one point, it's over the interval. Point concave up or concave down, and POI. So first thing, let's organize your space, work wisely. That is 3 plus sine x. First derivative, f prime of x is equal to cosine x, right? Derivative of. Now here, know the difference. We are not looking for critical numbers, but let's see what's the critical number. So this is a review from what we have learned in chapter 3.1, 3.2, 3.3. So if I have to find the critical number, this is cosine is 0 at pi over 2, 3 pi over 2. These are critical numbers. This is not point of inflection. They are not point of inflection. They are not point of inflection. These are just the critical numbers. So to find a point of inflection in concavity, you need a second derivative, prime of x. Derivative of cosine is negative sine x. Let's set it equal to 0. Sine is 0. Sine is 0 on this interval, 0 to 2 pi. Sine is 0 is at 0, pi, and 2 pi. Okay, so these are possible point of inflection, right? These are possible point of inflection. I would not say these are point of inflection, because point of inflection, take a look at the definition. One more time, these are possible point of inflection. Point of inflection has second derivative 0 and sign changes. So we still have to check for the sign changes. Cannot just say these are point of inflection. This, I call them possible point of inflection. These are possible point of inflection. Possible. We have to check the sign. So this is the sign chart for second derivative. We are making a sign chart for second derivative. 0, pi, 2 pi. My second derivative is negative sine x based on the unit circle. Normally on the sine graph on the top half of the circle 0 to pi, if I look at all STC, sine is positive here, but I have negative sign, so this is negative. Between pi and 2 pi, sine is negative, but then I have a negative sign, so this is positive. So what is the, let's write the answers. First, concave up, concave down. So this is the second derivative. So I would say f of x is, oh gosh, is concave down on the interval 0 to pi as f prime of x is less than 0. F of x is CC down, no, CC up. I already wrote down. CC up on the interval pi to 2 pi as f prime of x is greater than 0. Third thing, f of x has POI. We can confirm that the sign changes at pi. So f of x has a point of inflection at x equal to pi. The reason, f prime prime of pi is 0 and f prime prime of x changes sign. Oh, I forgot to write sign from negative to positive. Okay, so let's make connection. Does it look like we used to write for relative extrema? Remember, in f prime of x is 0 and f prime, which is exactly same as, this is very similar, that f prime of x has relative extrema at x equal to pi. So how do we know that all our information is correct? So we have learned in the pre-calc. Let's connect in a pre-calc. We know how this graph look like. Y is equal to sine x plus 3. So let's check our answer is correct or not. 1, 2, 3. Sine graph looks like this, right? And this is a 2 pi. This is 0 and pi. So let's confirm our answer is correct. F of x is concave down. Does it look like concave down? 0 to pi. F of x is concave up, pi to 2 pi, concave up. And this is POI, point of inflection, where graph changes concave down to concave up. So it was easy to see from the trig functions what happens if you have a polynomial. If you have a polynomial, unfortunately, you will have to do some more work. So let's take a look at another example where we have a polynomial. Okay, so determine the open intervals on which the graph of a function is concave up or concave down. Find any point of inflection, So this is a fraction. So derivatives are going to be a little bit complicated. So first of all, let's take a look at the first derivative, f prime of x. I'm going to give you the answer to here, low d high, high d low, x square plus 3, oh my gosh, square, low derivative of high is 0, minus 6 times 2x. This is my first derivative. Second derivative will be even complicated because we have to use the, so that will be, second derivative will be x square plus 3 to the 4th power. And if you do ho d high, high d ho, that would be a lot of things. I'm just skipping that part. I'm giving you simplified answer so that we can see what's happening. And to save the time, many times they give you ready second derivative. So let's understand. Function will never be 0. Notice that it will never be 0. So there are no critical numbers are at -3. There is no critical number. So know the difference between critical numbers and POI. I'm just listing critical number is x equal to 0. Possible POI are x equal to 1 and -1 from here. Critical numbers are from first derivative. Possible point of inflection are from the second derivative. Denominator will never become 0. X square plus 3 will never become 0. So if I have to make a sign chart for f prime prime of x, -1 and 1, denominator will be always positive, 4th power. And the numerator, you can see this is a parabola, opens up. So that will be positive, negative, positive. And my sign is this for f prime prime of x. And you can write the answer that f of x is cc up on -infinity to -1, 1 to infinity as prime prime of x is greater than 0. F of x is CC down on interval -1 to 1 as f prime prime of x is less than 0, and f of x has point of inflections POI at, we can clearly see the sign changes, positive to negative, negative to positive, so both values are point of inflection as f prime prime of x changes sign. I already wrote that f prime prime, oh, I should write that here. F prime prime of -1 is f prime prime of 1 equal to 0. So this is what the expectations are for concavity and point of inflection. I'm just explaining here. Sometimes you have to be wise enough to see what rule comes and how do you know that which one to use. So quick review here. You are given a nice polynomial, which is very simple one. If you have to find intervals, f is increasing, decreasing, what would you use? First derivative or second derivative? Well, first derivative, that's easy. If you have to find relative extrema, what would you use? First derivative. If you have to find concavity, what would you use? Second derivative. If you have to find point of inflection, second derivative. So I'm just making sure you know the difference between when to use first derivative, when to use second derivative. This is a very easy example. I would like you to try this on your own. And another simple one, I just want to include this in the video as well, is the bottom part here. Sketch the graph of a continuous function given these characteristics. So these are again very popular part in a free response question. F of 0 is f of 2, and that's a 0. So those are 0 and 2. You have to have those two continuous function. F prime of x is greater than 0 when x is 1. So that means you have to go up. F prime of 1 is 0. That means horizontal tangent at x equal to 1. You cannot show sharp turn. You have to come down. So take a look at this. This is a nice graph. There is only one way you can show that: decreasing, increasing. Now same type of graph here, undefined, which means this is 0, this is 2. You still have something going on at 1. But undefined means you can show sharp corner, and that will be satisfying this graph. So this is what we are going to do next, is how to sketch the curve based on the given information. If you are interested in doing homework after watching this video, I would recommend that you begin work on the homework question number 11 through 30. 11 through, it says 11 through 39, omit 23, 25. You can check on the cover page, homework assignment. You could begin on that. I will see you in the class on Thursday and Friday.